Assalamu alaikum everyone. Today's video is on index laws. The word index also means powers. Okay, and power tells you how many times a number multiplies by itself. So for example, 2 to the power 1 is just 2. It's multiplied by itself once. 2 to the power 3 is 2 times 2 times 2. And if someone asks you for the value of 2 to the power 3, that would give you 8. Okay, so we're going to look at some index laws today, and hopefully this will help. It's a very interesting topic. So if I have 3 to the power 2 times 3 to the power 4, what this would really mean is 3 to the power 2 is 3 times 3, right? Because 3 is multiplying by itself twice. Oh, by the way, I was mentioning earlier that another word for index is powers, and indices is the plural of index. Okay, so we'll come back to this. So 3 to the power 2 is 3 times 3, and 3 to the power 4 is 3 times 3 times another 3 times another 3. Now, if I was to write this as a power, I need to see how many times is 3 multiplying by itself. So that's 1, 2, 3, 4, 5, 6. So this number in index form is 3 to the power 6. Because there's 6 3's multiplying by itself, right? 1, 2, 3, 4, 5, and 6. But if I had to do these calculations in this way every single time, it would be quite tricky. So there's an easier way. You see this 3 over here? This has a special name. It's called a base. So if you're multiplying two numbers or letters and the bases are the same, the powers can be different, but the bases are the same. So there's a shortcut when you're multiplying. So I could do 3 to the power 2 times 3 to the power 4. If the bases are the same, then and you're multiplying, I can just add the powers. 3 to the power 2 plus 4, that is 3 to the power 6. Okay, now let's have a look at another example, right, with this particular situation. So this time I'm going to use some letters. So if I use x to the power 5 times x squared, again, instead of writing out 5x's multiplied by itself and another 2x's, the two bases are the same. I'm multiplying. Remember, this is not for addition or subtraction. This is multiplication here, right? So I'm going to write it as x to the power 5 plus 2, which is x to the power 7. Now, I'll show you an example when the bases are not the same. So if I have x to the power 3 times y to the power 2, the bases are not the same. So I write this as x to the power 3 y squared. That's it. I just leave it as it is. Okay. This will only work if the bases are the same. For example, if I have y to the power, say, 7 times y to the power 9, the bases are the same. So I'm going to add the powers up. Y to the power 7 plus 9, which is y to the power 16. Okay. So we'll look at some more examples, but this time this was on multiplication. We're still sticking to the same basis, and we're gonna go on to division. Right, so let's look at an example. This time we're looking at 2 to the power 5 divided by 2 to the power 3. Now 2 to the power 5 is the same as 2 times 2 times 2 times another 2 times another 2. And when you're dividing this, all of it is being divided by 2 times 2 times 2. So if I went to simplify, this 2 will cancel out with this because 2 goes into 2 once, and then this 2 cancels out. 2 goes into 2 once, and this 2 cancels out this. So I'm left with just 2 times 2, and that is 2 to the power 2, which is 4 basically. But I mean, writing is this answer in index 4. Again, when I'm simplifying this, the bases are the same as I mentioned before, and you're dividing, but this working out can take quite a while. So a quicker way, again, the bases need to be the same for this, is 2 to the power 5 divided by 2 to the power 3. The bases are the same, so I can then subtract the powers, which is 2 to the power 2. Let's try another example. 3 to the power 7 divided by 3 to the power 4. Bases are the same, so we're gonna go ahead, subtract the powers. 3 to the power 7 minus 4, that's 3 to the power 3. Okay, that's the answer in index form. We're gonna choose some letters now. X to the power, let's do 5 divided by x to the power 7, which is x to the power 5 minus 7, which will give you x to the power minus 2. Now again, same thing when the bases are not the same. So if I had x to the power 3 divided by y squared, I would write this as a fraction, x cubed over y squared. Okay, I cannot subtract the powers because the bases here are not the same. The bases here are the same. Okay, that was multiplication done, division done. Now we're gonna look at some special cases, and then we'll look at the power 0, we'll look at negative indices, we'll look at fractional indices. So before we look at the power 0, just quickly, we're looking at brackets. So if I have 2 to the power 3 to the power 4, now what this means is 2 cubed is multiplying by itself 4 times. So that would mean 2 to the power 3 times 2 to the power 3 times 2 to the power 3 times 2 to the power 3. And this would be 2 to the power 3 plus 3 plus 3 plus 3, which would give you 2 to the power 12. Once this is done, you look at this, 2 to the power 12. That's a long working out. So there's a quicker way. 2 to the power 3 to the power 4. Here I would just multiply the powers because there's 4 lots of 2 cubed. So I can just multiply it to give you 2 to the power 12. Okay, let's look at another example. X squared to the power 5. In this case, instead of writing 5x squared, x squared times x squared times x squared times x squared times x squared, you can just do x to the power 2 times 5, which is x to the power 10. This is, however, let's say 2x, let's make it 2x cubed to the power 2. This is a slightly trickier situation because this 2 needs to be squared as well. So I would write this out as 2 to the power 2 times x to the power 3 times 2, which would give me, let me figure this out. So 2 squared is 4, and x to the power 6, that'll be 4x to the power 6. Okay, so make sure when the numbers are there, you square that as well. Right, we're going to move on now to the zero power. So let's look at an example. Let's say 3 squared, right? Let's see how this is going to work. Now 3 squared divided by 3 squared. That's the same as saying 3 squared over 3 squared. Because in a fraction, this line over here is the same as division, right? So 3 squared is 9 and 3 squared is 9. However, on the left hand side I can write this as 3 to the power 2 minus 2 because the bases are the same and I'm dividing, so I can subtract the powers, and I know 2 minus 2 is 0, and then 9 divided by 9 is going to give me 1. So any number divided by itself is 1. So 3 to the power 0 is 1. Okay, so this, someone could say, hang on, this could be a special case with 3. What about if the base was any other number? So I'm going to take the base to be x, so I'm just going to shift slightly to the right, and then I'll look at another example. So I'm going to use x to the power 5, for example, divided by x to the power 5, and actually let me use a letter, right? So instead of a number, let's make it generic. X to the power a divided by x to the power a. That would be the same as x to the power a over x to the power a. And these two, x to the power a, are the same thing. So when you divide something by itself, you get 1. And this would be the same on the left hand side as a minus a, x to the power a minus a. And since a is the same as a, that would be x to the power 0. So you can see now x could be any number and a could be any number. So anything to the power 0 is 1. And the reason for that is anything to the power 0 is that number divided by itself. But you cannot have every number to the power 0. You cannot have 0 to the power 0. That is not possible because we have not figured out how to divide by 0 kind of yet. It's undefined here. So remember, even if I had a negative number, as long as it's in brackets, so minus 5 to the power 0 here is going to be 1. Because the minus 5 is in brackets, so it's basically minus 5 divided by minus 5. This is what it means, right? This is what it means. It means minus 5 divided by minus 5. So when I divide it by itself, it gives you 1. However, if I was to write this, the answer will come up as minus 1. And the reason for that is this particular calculation represents minus 5 over here divided by 5. So that would be minus 1. Okay, so if you are writing a negative number to the power 0, make sure you place in brackets. So remember, anything to the power 0 is that number divided by itself, and 0 cannot be put to the power 0 because 0 cannot be divided by itself. We haven't, dividing by 0 is undefined, so it's not defined. Let's leave it at that. Okay, now we're gonna come and look at negative powers. So let's look at an example. I'm going to look at a generic example. So what does x to the power minus 3 mean? Well, let's see. So x to the power minus 3 would be the same as x to the power 0 minus 3. Now we subtract powers when you're dividing and the bases are the same. So I can say this is the same as x to the power 0 divided by x to the power 3, right? The minus signifies dividing. And then I'm working backwards here. So I can write this as a fraction then, isn't it? X to the power 0 over x to the power 3. And we know that x to the power 0 is x divided by itself, which is 1 over x to the power 3. So the negative power signifies a reciprocal, really. And for those of you who do not know what a reciprocal is, so a reciprocal is basically when you have a fraction flipped over. Let me just try writing reciprocal here. Okay, so here's some examples. So the reciprocal of 1 over 5 would be 5 over 1. That fraction flipped over. 2 over 5. The reciprocal would be 5 over 2. So when dealing with a negative power, this here is the reasoning behind it, okay? But it's a very lengthy working out. It's the reasoning behind it though. So I'm going to show you a quick way of writing something as a negative power. So if I have 3 to the power minus 2, okay? So the first thing I'm going to do is I'm going to write 3 as a fraction. So 3 as a fraction is 3 over 1. And I'm going to put it to the power minus 2. Now, also, I missed an explanation for fractions. How are they affected by powers? But I'm going to go over it now. Now, in order to get rid of the negative sign of the power, so it's minus 2, I need to write down the reciprocal of the number. So the fraction, which in this case is 3 over 1. So the reciprocal of 3 over 1 is 1 over 3 to the power 2. And now both the numerator and the denominator will get the power. So you got 1 squared over 3 squared. 1 squared is 1, and 3 squared is 9. Okay, let's go over another example. Let's say 6 to the power minus 1. So first step, write 6 as a fraction, 6 over 1, put that fraction to the power minus 1. In order to get rid of the negative power, just the minus sign, you have to write down the reciprocal of the fraction. So 1 over 6, that would get rid of the negative power. It'll become a positive power now. And then both the numerator and the denominator get the power 1 to the power 1, 6 to the power 1. That's 1 over 6. Okay, one last example. 2/5 we used. So we'll do 2 over 5 to the power minus 3. Again, to get rid of the negative power, you flip it over. Sorry. So it's already as a fraction, written as a fraction. So we're going to start off by getting rid of the negative power. So it's going to be 5 over 2 to the power 3. Then the numerator and the denominator get the power. So 5 cubed over 2 cubed. And that's going to be 125 over 8. Okay. And then the last thing we're going to look at is, well, fractional powers. So now, before we start that, we did mention reciprocals. So the reciprocal of 2 is a half, right? Let me write the word reciprocal again. The reciprocal of 2 is a half. So it's, when you're looking at fraction powers, we have to kind of do the opposite. So if I was to say x squared, when I write it down, as we mentioned earlier, power tells you how many times the number is multiplied by itself. So x is multiplied by itself twice, right? Okay, so when I say, okay, x to the power half, it's multiplied by itself half times, it's basically the root. So the denominator tells you, the denominator of the fraction tells you what root it is. It's the opposite of squaring. Yep, so the opposite of squaring is square rooting. If I was to do x cubed, that's x times x times x. So the reciprocal of 3 is 1/3. So you're going to do the opposite of cubing. So x to the power 1/3 will be cube root of x. Okay, so that's the basics of how this works, and let's look at certain examples of how this would work. So if I had 16 to the power of half, that is going to be the square root of 16, which has two potential answers, 4 or minus 4. Okay, if I have 81, sorry, not 81, yeah, 81 is fine. 81 to the power 1 over 4. That's going to be the fourth root of 81. Now, if you're going to struggle to find the fourth root of 81 mentally, so I would suggest we write this down. 81, it comes in the 3 times table, so you divide it by 3. You just use prime numbers here. It's going to be 27. You divide it by 3 again, gives you 9. You divide it by 3 again, gives you 3. You divide it by 3 again, that gives you 1. So because it's the fourth root, you need a quartet, so 4 numbers to come out of the square root. So it's 3 times 3 times 3 times 3. There you go. That's one of them, so it's just 3. Now we're gonna make it a little bit harder. So I have, let's say, 8 to the power 2/3. So the first thing I'm going to do is I'm going to cube root the 8. Whenever I have a power which is a positive power and it's a fraction, I get rid of the denominator, because that's the hardest part at this moment in time. And the cube root of 8, I have to square that cube root. So cube root of 8 is 2, so it's going to be 2 squared, which is 4. And the reason I had to square it is because the numerator is 2. That's why it's 2. Now let's make it a little bit harder. Let's use a different number. 64 to the power minus 2 over 3 now. When I've got a negative power, whether it's a fraction or a whole number, the first thing I need to do is get rid of the negative power. So I'm going to write this first as a fraction, 64 over 1 to the power minus 2/3. Then to get rid of the negative power, I would write it as the reciprocal, so 1 over 64 to the power 2 over 3. Then I cube root both the numerator and the denominator. Which will give you 1 over 4 to the power 2. Cube root of 1 is 1, cube root of 64 is 4. And then both the numerator and denominator get squared. 1 squared over 4 squared is 1 over 16. Okay, and then one last example where we have a fraction. Let's say 27 over 64 to the power minus 2 over 3. I've used a lot of a lot of 2/3, but it works very conveniently with these numbers. So here it's already a fraction, so I need to get rid of the negative power first. So I'm gonna flip the fraction over, write down the reciprocal. That gets rid of the negative power, so it's 64 to the power 2/3. Then I am going to cube root both the numerator and denominator, so I'm getting rid of the denominator from the powers. So cube root, it's cube root because the denominator is 3. all of it to the power 2. Cube root of 64 is 4. Cube root of 27 is 3. I'm going to square both of them. So that gives me 4 squared over 3 squared, which is 16 over 9. And you can convert this into mixed number. 9 goes into 16 once, remainder 7 over 9. It's not necessary unless the question stated maybe. But there we go. Hopefully this helps. I hope I've covered everything with index laws. I hope this helps, and all the best with your studies. Thank you very much for watching.